Learning objectives. After studying this module, students will be able to understand the need of summarizing data, learn about different types of averages, know different way to measure arithmetic mean, calculate arithmetic mean, define mode and know how to compute mode, know about percentile, quartiles, median. Know the ways to calculate median. Measure of central tendency. Introduction. What is measures of central tendency? This is a numerical method to explain the data briefly. We use this method in our day-to-day life. For example, measuring the average marks of students in term-end exams, average rainfall in the area, etc. Significance of measures of central tendency. This method summarizes the whole value in such a manner that single value tells about the whole data. It is way of summarizing data in a representative value. Methods of measuring central tendency. There are many methods to measure the central tendency, but the three most commonly used methods are arithmetic mean, median, mode, geometric mean, harmonic mean. Arithmetic mean. It is refers to as the sum of the values of all observations divided by the number of observations. It is denoted by x. Suppose if there are n observations as x1, x2, x3 and so on till xn, then the arithmetic mean is given by x bar is equal to x1 plus x2 plus x3 plus and so on till xn upon n. Or it can be written as x bar is equal to summation of x upon n, where summation x is the sum of all the observations. How can we measure arithmetic mean? We can study the calculation of measuring arithmetic mean by two ways. 1. Arithmetic mean for ungrouped data. 2. Arithmetic mean for grouped data. Ways to measure arithmetic mean. Arithmetic mean for ungrouped data. We use the following methods to measure arithmetic mean for ungrouped data. Direct method. The arithmetic mean is calculated by sum of all the observations which are in series and then divided by total number of observations. Assumed mean method. This method is used when we have to calculate mean from a large set of data and there are large numerical observations. Then we can use assume mean method. The actual arithmetic mean is calculated by taking the sum of assumed mean and ratio of sum of deviations to number of observations. Let A is equal to assumed mean, x is equal to individual observations, n is equal to number of observations. D is equal to deviation of assumed mean from individual observations. That is, D is equal to x minus A. Then, sum of all deviations is taken as summation D is equal to summation x minus A. Find summation D upon n. Then, add A and summation D upon n to get x bar. Therefore, x bar is equal to A plus summation D upon n. Step deviation method. This calculation can be simplified by dividing the all deviations which we have taken from assumed mean by the common factor c. For example, if d is equal to x minus a is very large, then we can find d dash. The formula is d dash is equal to d upon c is equal to x minus a upon c, or x bar is equal to a plus summation of d dash upon n into c, where d dash is equal to x minus a upon c. C is equal to common factor. A is equal to assumed mean. Calculation of arithmetic mean for grouped data. The calculation of arithmetic mean can be done for different types of data in grouped data category. Discrete series. Direct method. In discrete series, frequency against each observation is multiplied by the value of the observation. The value that we obtain are summed up and divided by the total number of frequencies. The formula is x bar is equal to summation fx upon summation f, where summation fx is equal to sum of the product of variables and frequencies, and summation f is equal to sum of frequencies. Calculation of arithmetic mean for grouped data. Discrete series. Assumed mean method. The calculations can be simplified using the assumed mean method. The formula would be x is equal to a plus summation fd upon summation f. Step deviation method. In this method, the deviations are divided by the common factor c that helps to simplify the calculations. The formula is x bar is equal to a plus summation fd dash upon summation f into c. Continuous series. The method to calculate arithmetic mean in case of continuous series is same as of a discrete series, except that in continuous series, midpoints of various class intervals are taken, like 0 to 10, 10 to 20, or 0 to 9, 10 to 19, etc. Direct method. We need to find the mid value first for each class. Then find out summation fm and apply the given formula. X bar is equal to summation fm upon summation f. Step deviation method. Find out d dash is equal to m minus a upon c. X bar is equal to summation fd dash upon summation f into c. Properties of arithmetic mean. 1. The sum of deviations of items about arithmetic mean is always equal. 2. Arithmetic mean is affected by extreme values. Any large value can push it up or down. Weighted arithmetic mean. At times, it is important to give some weightage to the items as per their importance while calculating arithmetic mean. The formula to calculate weighted arithmetic mean is summation wx upon summation w. Median. Median is that value of a variable which is at such position that divides the distribution into two equal parts. One part comprises all values greater than or equal to the median value, and the other part comprises all values less than or equal to it. Computation of median. We can compute the median by sorting the data from smallest to largest and then finding out the middle value. Let us take the following observation in a data set: 5, 7, 6, 1, 8, 10, 12, 4, and 3. Arranging the data in ascending order, we have 1, 3, 4, 5, 6, 7, 8, 10, 12. The middle value is 6, so the median is 6. If there are even numbers in the data, then there will be two observations that fall in the middle. The median is computed as the arithmetic mean of the two middle values in that case. The formula would be median is equal to n plus 1th upon 2 item. Discrete series. In discrete series, the position of median, that is n plus 1 by 2th item, can be located through cumulative frequency. The corresponding value at this position is the value of median. Continuous series. In case of continuous series, you have to locate the median class where n upon 2th item, not n plus 1 upon 2th item, lies. The median can then be obtained as follows. Median is equal to L plus n upon 2 minus Cf upon f into h, where L is equal to lower limit of the median class. Cf is equal to cumulative frequency of the class. F is equal to frequency of the median class. H is equal to magnitude of the median class interval. Quartiles. This method divides the data into 4 equal parts. Each portion contains equal number of observations. There are 3 quartiles. The first quartile, Q1, has 25% of the observations below it and 75% of the observations greater than it. The second quartile, Q2, or called as median, has 50% of observations below it and 50% of the observations above it. The third quartile, Q3, has 75% of the observations below it and 25% of the items above it. Percentile and mode. Percentile. Percentiles divide the distribution into 100 equal parts. So, you can get 99 dividing positions denoted by P1, P2, P3 and so on till P99. In this, P50 is the median value. Calculation of quartiles. The method for finding out the quartile is same as that of the median in case of individual and discrete series. The value of Q1 and Q3 of an ordered series can be obtained by the following formula. Mode. At times, we are interested in knowing the value around which maximum concentration of items occurs. Like a manufacturer would want to know the size of purses that has maximum demand or style of the shirt that is more frequently demanded. So in such situations, mode is the appropriate method. Mode is the most frequently observed data value. It is denoted by MO. Computation of mode. Discrete series. Consider the data set 1, 2, 3, 4, 4, 5. The mode for this data is 4 because 4 occurs most frequently, twice in the data. When there is a unique value of mode, the data is unimodal. When you have data with 2 modes, it is called as bimodal. When more than 2 modes or more than is called as multimodal. If no value appears more frequent than any other value in the distribution, then there may be no mode. Calculation of mode. Continuous series. In this series, modal class is the class with largest frequency. So the following formula can be used to calculate mode. MO is equal to L plus D1 upon D1 plus D2 into H, where L is equal to lower limit of modal class. D1 is equal to difference between the frequency of the modal class and the frequency of the class preceding the modal class. D2 is equal to difference between the frequency of the modal class and the frequency of the class preceding the modal class. H is equal to class interval of the distribution. Summary. Let us summarize what we have learned in this module. Central tendency is a numerical method to explain the data briefly. Central tendency method summarizes the whole value in such a manner that single value tells about the whole data. Arithmetic mean refers the sum of the values of all observations divided by the number of observations. In direct method, the arithmetic mean is calculated by sum of all the observations which are in series and then divided by total number of observations. Assumed mean method is used when we have to calculate mean from a large set of data and there are large numerical observations. In step deviation method, the calculation can be simplified by dividing all the deviations which we have taken from assumed mean by common factor C. In discrete series, frequency against each observation is multiplied by the value of the observation. Quartile method divides the data into 4 equal parts. Each portion contains equal number of observations.